All right, so welcome to today's class. We'll be looking at atomic structure, and we'll be solving some of the questions on just the basic concepts that we can have in atomic structure. Okay, so here I've put first of all some definitions of important terms that we need to understand. Okay, and then thereafter we are going to look at some sample questions based on the same terms. All right, so a simple introduction to atomic structure. Okay, so atomic structure simply explains how the atoms interact with energy. Okay, so energy is transferred in the form of light. Okay, so when you're talking about atomic structure, then all the energy that we are going to be talking about, it will be transferred in form of light. Okay, and that light, okay, comes from what we call as the electromagnetic radiation. Okay, so later on, we'll talk about the electromagnetic spectrum. Okay, so this is just a spectrum that contains different types of radiations that are there. Okay, so we're going to discuss them. We discuss some important things that we need to know about them. Okay, like the wavelength, the frequency, and the energy. All right, so here I was saying to understand atomic structure, we must understand one, wavelength. Okay, we must understand frequency. We must understand the speed of light, which is as a constant. We must understand the energy that will be in form of the light. And then we must also understand what we call as the Planck's constant. All right, so we start with the wavelength. Okay, so what is the wavelength? Okay, so the wavelength is simply the distance between two consecutive crests or troughs, okay, of a wave. So if I write a wave here, okay, so let this is be my wave like that. Okay, so we're saying the distance, okay, between two consecutive troughs or crests is what we are going to be calling as what we are going to be calling it as wavelength. So this one I can write again something like that. So you can see the highest point here is what we call as the troughs. Then the lowest point of this wave, okay, these ones here are what you call as um, I mean, the highest point are called as the crests, and then the lowest point here are called as the troughs. So the distance between two successive crests, or the distance between two successive troughs, is what we call as the wavelength. So the distance from here all the way up to there, that's what we call as the wavelength. Okay. So the wavelength is indicated by the symbol lambda, and we write it like that. So whenever you see this symbol here, you read it as lambda, okay, and it means wavelength when you're on this topic, atomic structure. Okay, it can also be the distance between two successive troughs like these ones. Okay, it's just that my drawing is not accurate. So that distance here between this trough here and this trough here, we can also call it as the wavelength. So that's the definition. Okay, so the symbol you can see is lambda, and then the units for the wavelength. Okay, most of the times to do our calculation, we always have to calculate the wavelength or to express the wavelength in meters. All right, so the wavelength is inversely proportional to the energy. Okay, so meaning that when you have a very long wavelength, okay, then you expect your energy to be very low. So we're going to understand why soon. Okay, and then when the wavelength is short, then you expect the energy to be high. Okay. Again, I'm going to explain why in a very short period of time when we are talking about the wave equation. Okay, so that's all you need to know basically about the wavelength. And then we can talk about the frequency here. So if you are not able to see whatever I'm writing here, you can put your phone in landscape so that the screen becomes a bit bigger. Okay, for you to see properly. And then when you talk about the frequency, this is just the number of waves, okay? The number of waves passing through a point per second. Okay, so the total number of waves that will pass at a certain point per second, that's what we call as the frequency. So the frequency, the symbol is F or something that looks like a V, like this one. So we call this symbol here as nu. Okay, it's not V, but nu. So you find that some textbooks, they are indicating frequency as nu, or some are indicating it as what? As F. So don't be surprised. You can use these two symbols interchangeably. Okay, and then the units for frequency are what we call as hertz, or we can just say per second, like s to the power minus 1, this one here, or I just say 1 over s. Okay, so s to the power minus 1, okay, or 1 divided by s, which we read as 1 per second, okay, or just per second, or hertz. Okay, those are the units for the what? For the frequency. All right, and then when you talk about the frequency, it's directly proportional to the energy. So meaning when you have high frequency, you expect to have high energy, okay? If you have low frequency, you expect to have low energy. And I'm going to explain why this is so very soon. All right, and then the other thing that we need to talk about is the speed of light. Okay, so all the electromagnetic waves, they travel at the speed of light in a vacuum. And the speed of light has the constant value of 3.0 times 10 to the power 8 meters per second. Some textbooks, okay, will have 2.9, okay, 2.98 times 10 to the power 8 meters per second. But for us, in all our calculations, we're going to be taking the speed of light as 3.0 times 10 to the power what? 8 meters per second. Okay, so now between the wavelength, the frequency, and the speed, what is the relationship between those three? Okay, so the relationship comes in by what we call as the wave equation. Okay, so the wave equation simply says the speed is equals to the frequency multiplied by the what? By the wavelength. So now, remember I said um, if you have a higher wavelength, then you are going to have a lower frequency, right? So the reason is from this formula. So here in this formula, if I make this wavelength here, the subject of the formula, it will be wavelength is equals to C over F. So I can put this lambda here over 1. So you can see that the wavelength is on top and then the frequency is down. Okay. So whatever you'll be doing, whatever thing that you'll be doing to the wavelength, okay, the opposite thing is going to be happening to the frequency because this one is on top, this one is down. So we say that the wavelength and the frequency, they're actually inversely proportional, meaning that if the wavelength increases, okay, the frequency decreases. If the wavelength decreases, the frequency increases. Okay, so they are inversely proportional. No wonder we're making this statement here. Okay, we're saying long wavelength, okay. If you have a long wavelength, then you expect your frequency to also be what? Low. And then if the frequency is low, you have what? Low energy like that. Okay, it comes from this formula here. And then when you take a look at um, the wavelength and the speed, you can see both of them are on top there. Okay, so we say that those are direct proportional. So whatever you do to the wavelength is also going to happen to the what? To the speed. So if you increase this guy, the speed increases just like that. Okay, so that's when we are talking about the general speed. But when you're talking about the speed of light, the speed of light will just be what? Constant. Okay, so this is the wave equation. It's a very simple equation that as you have seen here, okay, but it's very much useful when we'll be solving questions on the waves. Okay, and then the other thing that we need to talk about, okay, is that we have to talk about the Planck's constant. Okay, so the Planck's constant is simply a value. Okay, it's simply a value. Planck's constant is simply a value. So Planck's constant is 6.63 times 10 to the power minus 34J. I mean, to the power minus multiplied by 10 to the power minus 34 joules second, like that. Okay, so these are the units there. So that is just the Planck's constant. So I've seen like in some examinations or in some tests, they will put this constant on the front cover of the chemistry paper. Okay, but some they don't put it. So it would be better if you just master it. Okay, so it's just 6.63 times 10 to the power minus 34. So that's the Planck's constant. It will be very important when we are finding the energy of a photon. Okay, so let's go to the energy of a photon, this one here. Another very important concept. Okay, so the energy of a photon is just the energy of a light. Okay, it's just the energy of light, and it's given by this formula that you can see there. So we are saying energy is equals to the Planck's constant multiplied by the what? The frequency. So now you can see here that the energy and the frequency, they are directly proportional. So if the frequency increases, energy increases. Okay, energy decreases, the frequency decreases. No wonder we are making this claim here. Okay, so I've explained that. So these are just some basic things that you have to know. Okay, and the formulas that you need to know in order to solve the questions that will come. And then uh, before I continue, are there any questions at this point? Anyone who has a question before we move? All right, so if there are no questions, let's move to the next thing that we'll talk about, which is the electromagnetic spectrum. Okay, so I've seen a lot of questions concerning the electromagnetic spectrum. So I'm going to explain the important concept that you should have in your what? In your mind. Okay, so the electromagnetic spectrum, as we said, it's just a spectrum that contains uh, electromagnetic waves, okay, or different radiations. So we have 7 different radiations on the spectrum. Okay, we have the radio waves, we have the microwaves, we have the infrared, okay, radiation, and then we have the visible light, which is very important. Okay, the visible light is the most important electromagnetic radiation. And then from there, we have the ultraviolet, okay? And then we have the X-rays, and then we have the gamma rays. Okay, so the way these radiations are arranged on this spectrum, okay, it's in a way that is organized, okay? So it is based on the wavelength and the frequency, okay? So when I say wavelength, and then frequency. The frequency is the same as energy. So some books, they will say wavelength and energy. Some books, they will say wavelength and the frequency. Why? Because the effects of the energy and the frequency, they're actually the same. Okay, so the most important thing that you have to know about the electromagnetic spectrum, okay, is the order in which they are arranged. Okay, um, from which end do we have the highest wavelength? Okay, on which end do we have the lowest wavelength? And on which end do we have the highest energy or the highest frequency? And on each end do we have the lowest frequency or the lowest what? Energy. Okay, so I'll take this here as my left hand side. Then I'll take this one here as my right hand side. Okay, so when you start from the left, okay, going to the right, okay, you can talk about the two things that we've stated. So if I'm starting from the left, going to the right, okay, I can talk about the wavelength. What will be happening to the wavelength? Okay, so as you move from the left, okay, where you have the radio waves there, as you move from the radio waves to the gamma rays, okay, the wavelength is going to be reducing, okay? The wavelength is going to be what? Decreasing. So the wavelength decreases as you move from the radio waves to the gamma rays, okay? And then as you move from the gamma rays to the radio waves like that, or in this, for this picture, we can say from the right to the left, okay? The wavelength is going to increase, okay? The wavelength is going to do what? Is going to increase. So meaning that, okay, meaning that the radiation that has the largest wavelength is actually what? The radio waves. So that's a key point to take note, okay? The radio waves have the largest wavelength of all the radiations on the spectrum. And then the gamma rays, okay, they have the smallest wavelength, okay? they have the smallest wavelength. So now remember the relationship. We had the speed of light is equals to the frequency multiplied by the wavelength, right? And then I made the wavelength to be the subject. So I remained with the speed of light over frequency. So he said here the wavelength and the frequency are actually inversely proportional. Okay. And then from the other formula, we saw that energy is directly related to the what? To the frequency. So meaning energy is direct proportional to the what? To the frequency. So meaning that since these radio waves here have the largest, okay, they have the largest wavelength, they are going to have the smallest frequency. Okay, since these radio waves have the largest wavelength, they are going to have the smallest what? Frequency. Okay, because why? These two are inversely proportional. Okay, and then since the gamma rays here have the smallest wavelength, it means they are going to have the largest what? Frequency. And if they have a larger frequency, based on this equation here, which is direct proportional there, okay, if they have the larger frequency, they are also going to have the larger energy. Okay, so as we move, now I'll be talking about the frequency. Okay, so we can clearly see there as I move from the radio waves to the gamma rays, okay, in terms of the frequency, okay, the frequency does what? Decreases as I move from the radio to the gamma. I mean, the frequency increases, sorry. Okay, as I move from the radio to the gamma, the frequency increases. And then as I move from the gamma to the radio, okay, my frequency does what? Decreases. So here you can see I was putting some to my numbers here. So you can see this is 5 billion nanometers. Okay, this is 5 billion nanometers. And then as I'm moving to the right here, or as I'm moving from the radio waves to the gamma rays, you can see the wavelength, the wavelength where I'm moving towards to. This is 0.0005 nanometers. So you can see this is the smaller one, this is the bigger one. Then when I'm talking about energy, okay, which is just the same. When I'm talking about the frequency, you can see that moving from the radio, I have a very smaller frequency there as compared to the energy that I'm having there. Okay, I mean, this is actually energy, not frequency. So I have a very low energy here. And then as I move from the radio waves to the gamma rays, my energy does what? Increases. So that relationship, you have to have it in your mind. Okay, it has to be there. You have to understand that concept. Okay, so now, how do you make sure that you know these things? Okay, or that these things actually stick in your head? Okay, so I've made a very simple mnemonic that you can actually use to remember the order of the electromagnetic what? Radiations. Okay, so this is the mnemonic here that I've put there. Okay, so you can just memorize this part here, and then it will be telling you the type of radiation that you have. So the mnemonic goes like, raging Martians, okay, invaded Venus using X-ray guns. Okay, raging Martians invaded Venus using X-ray guns. So the raging here, okay, you can just be getting to my first letters there, okay, to form the radiations. So the raging here, the R simply means the radio waves. The Martians, it means the microwaves. Invaded, it means infrared. Okay, and then the V in Venus means the visible light, which is the most important radiation. And then U is the ultraviolet, X is the X-ray. Okay, so this is just the same. GANs, the G is for the what? For the gamma rays. So you can just memorize this, okay, and then you'll be able to remember the radiations in order, okay? And then you just have to know one of the two. Either you know the trend for the frequency or you know the trend for the wavelength. Because if you know one, then the other one will just be the opposite of whatever you've known. So you just choose if you're going to memorize the wavelength or you're going to memorize the what? The frequency. So from the radio waves, okay, to the gamma rays, we said the wavelength does what? Decreases. So you can just memorize this one, okay? You just know that, okay, from the radio waves to the gamma, the wavelength decreases. So if that happens in that direction, then it means in that same direction, the opposite should happen to the frequency, okay? And whatever happens to the frequency is the same thing that happens to the what? To the energy. So that's how you memorize these things. All right, so any questions there, guys? Any questions? Okay, so I forgot to mention one thing. So visible light, remember I said it's the most important radiation, right? So visible light has also its own spectrum. So you can see here for the visible light, this part here, you can see this spectrum that it forms. So this spectrum now, I know that you know it. So you remember this word that we are saying in secondary, we're saying Roig beam. Okay, so it is the visible light that forms the Roig beam. So the Roig beam is just a spectrum of the colors, okay? The colors of the light. So there's red, orange, a yellow, a green, um, blue, and then there's indigo there, and then there's violet. Okay, so without the visible light spectrum, then we won't be able to see anything. So what you are seeing right now on the screen, it's because of the visible light. Okay, if there were no visible light, then we would not see anything. It would just be dark. Okay, to just be dark. All right, so I've explained this, and then I've also explained the terms. So that let's now try to answer some simple questions based on just this concept that I've explained. So we start with the first one here. Okay. So the first one here, it's a question about comparing the electromagnetic what? Waves. Okay. So here they're saying two electromagnetic waves, wave one and wave two. Okay. All right. And then they're saying wave two has a shorter wavelength than wave one. Okay. So before we can even answer this thing here, okay, before we can even answer this thing here, um, I'm going just to write that mnemonic. So that mnemonic, remember, it started with the radio waves and then it ended with the uh, gamma rays. Okay, and then we said from the radio waves to the gamma rays here, what was happening to the wavelength? Okay, so wavelength was decreasing. Okay, wavelength was decreasing like this. So it means if I'm moving from these same radio waves to the gamma, okay, my frequency will just be what? Increasing. And whatever happens to the frequency also happens to the what? To the um to the energy. Okay. So here we've been told that wave one has a shorter wavelength than wave what? I mean wave two has a shorter wavelength than wave one. So since the wavelength is decreasing like that, so I'm going to have wave two somewhere there and then wave one somewhere there because it's decreasing as I go in this way. Okay, and then A, what was the question? They're saying which wave has higher frequency? Okay, so which wave has higher frequency is the one with the shorter what? With the shorter wavelength. So I'm going to say wave two. I'm just going to write W2 there. Okay, and then B, they're saying if one wave is visible light and then the other is infrared radiation. Okay. Um, Okay. What was I trying to do in this question? I would say if one wave is visible light and then the other is um, infrared radiation, which one is which? Okay, so between the wave one and the wave two, which one is visible light and then which one is infrared what? Radiation. That's what they're asking you to do. Okay, so which one comes first? Okay, which one comes first between the infrared and the visible light? Okay, so from the electromagnetic spectrum that we are looking at, which one came first? Anyone who can answer. Okay, which one came first between the visible light and the infrared radiation? Hello, come on, guys. You didn't see the electromagnetic spectrum that I put there. Which one came first between the visible light and the infrared radiation? If I'm moving from the radio to the gamma. Okay, so Um, this is what I was talking about. So you need to know the electromagnetic spectrum. So it's just here. Okay, I was just showing you here. Okay, so you can see that the infrared here, comes before the visible light. Okay, so meaning this guy here, the infrared, actually has it has a longer wavelength than the visible light, because we said from the radio to the gamma, the wavelength is actually what? Decreasing. That's what we said. Okay, so when I go here, in answering B, I would say that wave one is the visible light. Okay, and then the wave two will be the infrared radiation. Okay, so that's the answer there. And then part C, they're saying if one wave is blue light and the other is red light, which one is which? Okay, so this one, blue light, red light, it comes from the visible light. So remember the visible light, I said it produces that little spectrum of colors where we said it is organized in this way, Roy G. Bev, like this. Okay, so I can see red there. I can see the blue there. Okay, so remember wave 2 has a shorter wavelength than wave 1. So between wave 1 and wave 2, which one will be blue light and which one will be what? Um, red light. Okay. Okay, so um, blue light versus red light. Okay, so which one do you think has a shorter wavelength? Okay, it's the same thing. Okay, just look at the electromagnetic spectrum. When I'm coming from the radio waves, going to the gamma waves, I'll find visible light somewhere, right? And then we said visible light here, it breaks down into the Roig beam, like this. Okay, we said from the radio waves to the gamma rays. Okay, as I pass through this visible light like that, okay, the wavelength is decreasing like that. So even for these individual colors, it will follow the same trend. So it means the wavelength of this guy is greater than this. Okay, the wavelength of this is greater than this, the wavelength of this is greater than this, the wavelength of this is greater than this, just like that. So of these colors, the one which has the lowest wavelength will be the violet, and then the one with the highest wavelength will be the red. Okay, so since we have blue and red, the red one will be the one with the longer wavelength. Okay, and then there they stated that wave 2, okay, is the one with the shorter wavelength. So blue here is the one with the shorter wavelength than the red. So I'm going to say wave 2 is blue light. Okay, and then wave 1 is actually what? The red light. Okay, because the wave 1 will have a longer wavelength. All right, so any questions there on how to answer this question here? All right, we'll move on to part 2. So let's look at this very simple question. So this one tests your knowledge on the frequency obtained from the wavelength. So they're saying yellow light, okay, from a sodium vapor lamp has a wavelength of 589 nanometers. Calculate its frequency. Okay, so you notice here they've just given us the wavelength. They're asking us to calculate the frequency. Okay, so how are we going to do that? We use the wave equation. So the wave equation says speed of light is equals to the frequency multiplied by the wavelength. So I'm trying to calculate the frequency. So frequency will just be the speed of light over the wavelength. So now the secret here and the mistakes that you guys mostly make is that you don't consider the units there. So when you take a look at this guy here, you can see this is nanometers, okay? But when I was explaining what the wavelength is, I said the wavelength should be in meters, okay? Unless they've specified that find the wavelength in nanometers. Okay, that's the only time you can leave it in nanometers. So you always leave it in what? The meters. So it means before I can use this guy, I need to do unit conversion, okay, to convert these nanometers to meters. Okay, no wonder when we started the lessons in December, okay, the holiday, we started from the unit conversions, how to convert units, so that we can be using them in all these other topics. So we have to convert this. So we said we can convert this using dimensional analysis, conversion factors, or using the direct metric system. So of those three, with the one that we said was the simplest was the metric system. So the video is there on the app. Okay, you can watch it at your own time if you missed that lesson. So this is 589 nanometers. So I'm just going to replace, okay, this nano with its value from the metric what? System. Okay, so this will be 589. Then the nano is the same as 10 to the power minus 9. This guy here, they can n. And then I remain with the meters. It means I've converted my wavelength to what? To meters. And then I can divide now. So the speed of light, it's a constant value. So they won't give you because they know that you already know it. So the speed of light is 3.0 times 10 to the power 8. That will be meters per second divided by the wavelength. So that is 589 multiplied by 10 to the power minus 9 meters. Okay, so this is just going to be equals to. So you can just direct punch this on your calculator, okay? Or you can do it step by step. Okay, so when you're doing it on the calculator, make sure you are very careful with how you're punching these values, okay? So if you want to punch this direct on the calculator, you first write this guy here, okay? So you write 3.0 times 10 to the power 8, and then you put it in brackets like this on your calculator, okay? And then you say divide by, and then you also write this guy in bracket like that. And then you divide, and then the answer is just going to show for you. Okay, so according to my calculator, you should confirm with yours as well. I'm finding 5.09 times 10 to the power 14. And then the units for the frequency, we said it's per second, like this, okay? Or we can say second to the power minus 1, or we can simply say hertz. So hertz, we represent it by HZ like that. Of course, I've rounded this to 2 decimal places like that. All right, so any questions on how we found the frequency? Right, next question. Okay, same concept. So here they're saying a laser used in orthopedic spine surgery produces radiation with a wavelength of 2.10 micrometers. Calculate the frequency of this radiation. So it's the same. So just be the frequency is equals to the speed of light, 3.0 times 10 to the power 8 meters per second, divided by this one here is in micrometers. So we have to change it in to meters. So this will be 2.1 multiplied by this micro here. From the matrix table, we said micro is the same as 10 to the power minus 6, like that. So I'll replace this micro, this symbol here. It's called micro, okay, in relation to the units. So I'll replace it with its value, which is 10 to the power minus 6, okay? And then that will be meters. And then I'll just punch this now onto the calculator. So make sure you put this in brackets like this, even this in brackets like that. Okay, so let me do that. You can also confirm with your calculator. All right, so my calculator is giving me 1.43, rounded off to 2 decimal places, multiplied by 10 to the power 14, and then hertz. Okay, so that is the frequency there. So any questions there? Okay, we'll move on to the next question. The next question, they're saying, arrange the following electromagnetic waves in order of increasing wavelength. Okay, arrange the following in order of increasing wavelength. Okay, so in increasing wavelength, okay, how are we going to arrange them? Okay, so you just have to, first of all, recall the order that you had memorized. Okay, and then from that, you're going to arrange them properly. So I want to arrange them in increasing order of what? Um, in increasing order of radiation. Okay, so you can see there's infrared, okay, there's radio waves, there's X-ray, there's ultraviolet, and then there's visible light, but they have given the specific colors for that light. Okay, so there's green, there's red. Okay, so how are we going to handle those? Okay, so remember, we said what we are going to memorize is that our electromagnetic waves or electromagnetic radiation, they start from the radio waves, okay, and then they go to the what? To the gamma. Okay, start from the radio to the gamma. Okay, so from the radio. Between the radio and the gamma, there are other um, five electromagnetic waves. So who can remember them in order? Who can try to remember them in order? I even gave a mnemonic there. If you had mastered that mnemonic, then this would be very simple to fill the gap. So anyone who can remember? Anyone who can remember, guys? We gave the mnemonic. Okay, so the mnemonic was it? Raging Martians invaded Venus using X-ray guns. Okay, so it means here the ones that are missing are actually the microwaves, okay, and then the infrared. Again, from there you go to the visible light, and then you go to the you go to the ultraviolet, and then you go to the X-rays. These are what are missing here. And then we said from the radio waves, okay, to the gamma rays, what is happening to the what? To the wavelength. We said the wavelength from here to there is actually what? Decreasing. Okay, so wavelength here is actually decreasing. All right, so now they want us to arrange whatever we have here in order of increasing wavelength. So we start from the smallest, okay, and then we go to the highest. That's what they want us to do. Okay, so of these ones that are given, you can see that the lowest here is the X-rays. So I'm just going to number the X-rays as 1 because it's the lowest. Okay, and then after the X-rays, you go to the ultraviolet. Okay, and then from the ultraviolet light, you go to which one now? So you see that from there, from the ultraviolet, you need to go to the visible light. But on the visible light, they've actually given us the specific light. So it means here I have to divide this visible light into its spectrum. So we said its spectrum for the visible light is Roig-Bev. Roig-Bev like this. Okay, so there they've given me green and red. Okay, so remember the wavelength is decreasing like this. Okay, it's decreasing like that. So meaning this one has the lowest wavelength as compared to the what? To the red. So here there's green and red. So red has the highest, okay, and then green has the lower one than the red. Okay, so it means the green is going to be number 3. Okay, and then the red is going to be number 4. So now I'm remaining with the radio and the infrared. So between the infra and the radio, which one has a lower wavelength? Okay, so the infrared are the ones, so I'll put them as 5, and then and the lowest are just going to be the radio waves. So now if I'm going to arrange them in increasing order, okay, I'm going to say the first ones will be the X-rays because they have the lowest. And then from there, the ones that are going to come are going to be UV light. What am I doing now? Ultraviolet, that's UV. Okay, so ultraviolet, that's UV. Then from the ultraviolet, I go to the 3, which is green light here. So I'll just say green light. Then from the green light, I go to the red light. Then from the red light, I go to the, which one was number 5? The infrared. Okay, so infrared there. And then from the infrared, my last one would just be what? The radio waves. Okay, so this one here is actually in increasing order. Of wavelength. All right, so any questions there? Okay, so from there, we'll look at the last question for today, which will be on the energy of a photon. So here they're saying calculate the energy of a photon with the wavelength of 3.3 micrometers and compare it with a photon of wavelength 0.154 nanometers. Okay, so here they want us to calculate the energy of two photons. Okay, one with a wavelength of 3.3 micrometers. The other one has a wavelength of 0.154 nanometers. Okay, so from here now, we just have to recall the formula. Okay, we have to recall the formula for the for the energy of a photon. So you said the energy of a photon is equals to, okay, remember the formula was the Planck's constant multiplied by the frequency. Okay, but here I've been given the wavelength. So what did I do? So remember from the wave equation, this one, okay, I can make this frequency to be the subject of a formula. So it will be frequency is actually equals to C over wavelength. So here where there's F, I'm going to put what? C over wavelength like that. Okay, so that will be the formula that we're going to use to find the energy there, because this one is just the Planck's constant, this one is just the speed of light, and we know the values of those, and then these ones will be given. So the most important thing, first of all, is to change this wavelength here into meters. So this will be equals to 3.3 multiplied by the micro is the same as 10 to the power minus 6 meters. Okay, so the energy for the first one will be Planck's constant, remember it was 6.63 multiplied by 10 to the power minus 34, then multiplied by the speed of light, which is 3 multiplied by 10 to the power 8, divide by the wavelength, which is 3.3 multiplied by 10 to the power minus 6. So what are we going to get here as my energy? So that energy that you get from here is going to be in joules. Okay, so you can try it out at your own time, okay? But the answer that I got when I was doing the calculation is 6.03 multiplied by 10 to the power minus 20 joules. So check this, okay? Check this on your own free time, check it. All right, so that is the first energy of this photon here. We also have to find the energy of this one here. So I'll say here, this is the same as 0.154 multiplied by nano, it's the same as 10 to the power minus 9, and then these will be meters. So it means the energy will be equals to, I'm using this formula here, okay? Planck's constant. Mary, you're writing on the screen. Let me cancel the annotations for you guys. Okay. Okay, so then we multiply with the speed of light, and then we divide by the wavelength, which is just 0.154 multiplied by 10 to the power minus 9 meters. Okay, you can even ignore the units. Okay, so you just punch this on your calculator. Okay, so try to see if you find the same answer as me. When I did my calculation, I found that this was 1.29 multiplied by 10 to the power minus 15 joules. Okay, so that is the energy of this photon that has this wavelength here. Okay, so the question was what? Calculate the energy and compare. Okay, so we can now make the comparison, okay, between this photon that has this energy and this photon that has that energy. Okay, so we are going to say, okay, because when you look at these values here, if I look at this value and this value here, this is times 10 to the power minus 20. This is times 10 to the power minus 15 there. Okay, so it means that this guy here, okay, this guy here is smaller than this guy here, okay, in terms of the magnitude of this number, because this is minus 20 and then this is minus 15. So when you when you're talking about negative numbers, okay, the bigger one is smaller than the smaller one. I don't know what I'm saying now, but yeah, so this minus 20, we know it's smaller than the what? The minus 15. So it means this energy here, okay, this energy here is smaller than this energy here. So in our comparison, we are going to say that the photon, okay, or the photon that has the wavelength of 0.154 nanometers has much higher energy, okay, than the photon that has the wavelength of 3.3 microwatt meters. Okay, and this is consistent with what I was explaining at the beginning, okay, because this is micrometers, this is nanometers, okay, so meaning that if I convert this nanometers to micro, okay, meters, what is it going to give me? Okay, so when you basically do that conversion, okay, if you convert the 0.154 nanometers to micrometers, uh, okay, if you did that conversion, the answer that you're going to get there is going to be simply what would be that now? The 0.154 nanometers is the same as the 1.54 times 10 to the power minus 4 micrometers. So now if I compare this wavelength to this wavelength, you see that this one here is greater than this wavelength here. Okay, so it is consistent with what we are saying at the beginning. If the wavelength is big, then the energy is going to be smaller. If the wavelength is smaller like this one, then the energy is going to be big. No wonder the energy for this photon with this wavelength, this one, is greater than the energy for this photon, this one here. All right, so any questions that you have, guys, on what we've done? Any questions that you have on what we've done? All right, so if there are no questions, I'll end here, but I have an assignment for you. So you can check out this question here. You can try to find the correct answer. So you can just take a screenshot and then at your free time, you try to um, answer it. Okay, so once you answer it, make sure you share the answers with me so that I know if what you're doing is actually correct or it's wrong. All right. All right, so those who'd like to actually register for our lessons, you're welcome to register. Okay, you can check the link in the description below here. It's going to guide you on how you can create an account on our website, which is discretelearning.com. Uh, and then also you can actually register for the course of your choice. So that's how you can make the payment, and then you'll be able to access our mobile app. Okay, as well as our website. Okay, so if you want the mobile app, just go on Play Store and search for Discrete Learning Institute. So the mobile app is going to come, and the mobile app is going to allow you to download the videos. Okay, so these videos that you are going to download, you can watch them offline. Okay, from anywhere. So you can be able to watch them offline at any time. Okay, so let me show you the website. So you just come to Play Store here. You come uh, to Chrome, then you type in discretelearning.com and then you click search. So this is the website that's going to come. So if you don't have an account, there will be an option to create an account. So just put in your details there, your email, and then you set your password. And then you'll be able to log in with those same details. Okay, so when you come here, you can find the courses here. So physics, math, chemistry, biology is there for first years. Okay, so if you want to learn anything, we have videos here. So for example, chemistry. If I open chemistry, okay, you have to go to this folder here, general chemistry. So once you open general chemistry, you're going to find the topic lessons, summarize notes, tutorial sheets, past quiz, test and exam papers, and lab report samples. Okay, so topic lessons, you can go there. So for example, we are doing a part of atomic structure in this video, okay? But here on the website, we have a full video on atomic structure. So all the concept. Okay, so you can see here atomic structure. So if you go here, you're going to find all the lessons for the atomic structure. Okay, you can see electrochemistry is there, chemical kinetics, chemical equilibrium, whatever you want is here. Okay, so make sure you take advantage, you register, and you learn at your own time, at your own pace, even in your what? Even in your blankets. Okay, and also we have videos to tutorial sheets. Okay, videos to past exam papers, tests, and quizzes so that you can use to revise and pass your assessments. Okay, so thank you so much for watching this video. This has been Tutor Solutions. Until next time, always there for you.